Hello, in this class I would like to talk about helium neon laser. Helium neon laser was the first gas laser. It was fabricated by Ali Javan, Iranian scientist, in 1961. So just after 1 year of ruby laser, the first gas laser, that is helium neon laser, was invented by Ali Javan. Here, as the name indicates, a mixture of helium and neon gas is the lasing medium. And electrical discharge is the method of pumping. Electrical discharge is used for pumping. Let us discuss the construction of a helium neon laser. So the helium neon laser consists of a long narrow discharge tube of diameter 1 centimeter and length about. In the last class I have mixed up these things. So actually the length of the helium neon laser is about 80 centimeter. There are helium neon laser with a 50 centimeter length as well. Okay, and the diameter of the tube is very narrow, that is about 1 centimeter, and this is filled with this discharge tube is filled with a mixture of helium and neon gas. Okay, so let us draw the diagram here. Here a discharge tube is there, and this is the discharge tube. Mixture of helium and neon gas is filled at a low pressure in the pressure ratio 10 is to 1. 10 is to 1 is the helium neon ratio. Okay, so you for example, this is 1 torr pressure in helium, 1 torr, and 0.1 torr pressure. Torr is 1 mmHg. Okay, millimeter of mercury. So this is the unit of pressure. Okay, the normal atmospheric pressure is at sea level is 760 millimeter of mercury. Okay, so this is just 1 torr of pressure of helium and 0.1 torr pressure of neon, and there are two electrodes. Of course, if it is a discharge tube, there will be two electrode, one anode and one cathode, and connected to a high voltage source. Okay, and this gas is enclosed between two mirrors. One is completely reflecting mirror, 100% reflecting mirror, and this is 99% reflecting mirror, that is partially reflecting mirror, and this act as the output coupler. Okay, so laser coming out of this laser through this mirror. Okay, so this is laser beam. Okay, so very simple. It consists of a discharge tube in which helium and neon gas mixture is taken. This act as the lasing medium, and this is enclosed between two mirrors, and there are two electrodes which are connected to a high voltage source. The two mirrors and the space between the gas filled space between these two mirrors act as the resonant cavity or lasing cavity, we can say. So the cavity means the space between two mirrors. Okay, so it is filled with the gas, so this is called a resonant cavity. This is the construction of a helium neon laser. Now let us talk about the working of helium neon laser. When a discharge is passed through the gases because of this high voltage, electrons are accelerated towards the anode. Okay, so these electrons from this cathode is accelerated towards the anode. So they collide with the helium atoms in the gas mixture and excite these helium atoms to higher energy levels. The helium atoms are excited to the levels F2 and F3 from the ground level F1. So let me draw the energy level diagram here. So this is energy level F1 of helium, and these are F2 and F3 of helium. Okay, so these are the higher energy levels of helium atoms. Here these two levels are metastable states. Okay, metastable states. And some of the excited levels of neon atoms correspond approximately to the same energy of the excited levels F2 and F3. So the neon atoms have also say excited levels with the same energy as F2 and F3. So this is neon energy level diagram. Here the ground state of neon is represented by E1, and there are excited state with the same energy as F2 and F3, and there are other energy level as well. Here this is energy level E2, and here energy level E3 is there. So I have separately drawn this here, E3, and this is E4, this is E5, and E6. Here E4 and E6 also have same energy as F2 and F3. These are E4 and E6 also metastable states. Metastable state. And E2 is intermediate energy levels. So when electrons excite these helium atoms to higher energy levels, they collide with the neon atoms in the ground state. Okay, so there are helium atoms and neon atoms in the gas mixture. When helium is excited, they collide with the neon atoms, and a transfer of energy happens between helium and neon. So the excited helium release energy to the neon, and neon atoms will be excited from E1 to E4 and E6. So here E4 and E6 are also metastable state, and these helium atoms will be de-excited back to the ground state. Okay. So ultimately, when a discharge happens, there will be more and more neon atoms will be excited towards E4 and E6. So this causes a population inversion between the levels E6, E4, and the lower energy levels E3 and E5. So this causes a transition, different kinds of transition. So this transition corresponds to a wavelength. This corresponds to a wavelength of 3.39 micrometer, whereas this energy transition, this transition of neon atoms corresponds to an energy of 6328 angstrom unit, and this transition between E4 and E3 correspond to a wavelength of 1.15 micrometer. 3.39 micrometer is in IR, and this transition also in IR, whereas this 632.8 nanometer or 6328 angstrom unit is visible. Okay, this is actually red light. The most common wavelength obtained from a helium neon laser is this wavelength, 6328 angstrom unit, which is a red wavelength. A specific wavelength can be selected from these wavelengths by using a bandpass mirror. A bandpass mirror is the one which reflects only a small band of frequencies. Helium and neon have many other energy levels, so therefore there are other wavelengths as well. Okay, so we are not going to discuss here. We discuss only these three wavelengths. Okay. And also one more thing, the typical power output of helium neon laser is between 1 to 50 milliwatts. 1 to 50 milliwatt is the power output of helium neon laser generally. Okay. Now gas lasers are more directional and more monochromatic. Gas lasers, because they have sharp energy levels. whereas the solid state lasers have bands of energy. So the gas lasers are more monochromatic, single wavelength. So this is about the helium neon laser. Now let us do an example problem. So this is the question. How many number of photons are emitted per second if the output of a helium neon laser is 50 milliwatt at a wavelength of 6328 angstrom unit? Okay. So the number of photons per second is asked. So we know the power is equal to 50 milliwatt. Actually, power is what is power? Power is energy per unit time. Energy per second is the power. Okay, so we get energy. So this is actually 50 millijoule per second. Now number of photons, how to calculate it? So for that, first we want to know what is the energy of a photon. Energy of a photon is given by h into nu. H is the Planck constant, nu is the frequency. Or in terms of wavelength, we can write this thing as hc divided by lambda, where c is the velocity of light in vacuum, 3 into 10 raised to 8 meter per second. H is 6.625 into 10 raised to minus 34 joule second. Lambda is, here lambda is given 632, sorry, 6328 into 10 raised to minus 10 meter. 1 angstrom is 10 raised to minus 10 meter. So substituting this thing, we'll get this is energy of a photon in joule. Now, so the number of photons per second equal to the total power divided by 3.14 into 10 raised to minus 19 joule is equal to 1.6 into 10 raised to 17 photons. So a large number of photons are released from the laser per second.